Okay, it's recording now. All right, so again, we're going to talk a lot about fossil fuels at the end of this unit with acid rain and smog. Obviously, greenhouse gases, which will come up when we learn about climate change. But we got to have first an understanding of the atmosphere, and so that is this: it's a dynamic system, meaning it's not static; it is changing. There's inputs, and there's really only two inputs to the atmosphere. We basically ignore meteors because meteors are a rare occurrence, but in general, there's two inputs to the atmosphere, and that is insolation and heat. Only one output, which is heat. Um, Realize that those inputs and outputs are energy, not matter. So that makes this a what type of system?
Closed.
Closed system. Good. If nothing was coming in and out, it would be an isolated system. If there was matter coming in and out, it would be an open system. But since it's just energy going in and out, it is a closed system. Um, the storages of the atmosphere are gases and water. They also flow. A great example would be think about the ocean. The ocean is not part of the atmosphere. The ocean is filled with water and gas, yet that water evaporates. Those gases, like carbon dioxide, go from the atmosphere into the ocean and then from the ocean back into the atmosphere. And so those would be flows in and out of the atmosphere. And changes that occur in the atmosphere are natural and anthropogenic. Examples would be when algae evolved, oxygen was created in the atmosphere for the first time ever. An anthropogenic example would be the fact that we dig up and burn coal and oil and gas, and that adds carbon dioxide into the atmosphere. Questions on this? Okay, there's four layers of the atmosphere. And by the way, guys, this is posted on Edmodo just like any other notes would be. So if you get behind, or again, if you have to leave early for a meeting, you could come back and listen to this recording, or you could just uh, pull up the PowerPoint on Edmodo. Either way would be fine. So, anyways, four layers of the atmosphere. Um, these are the most important layers: troposphere and stratosphere. The troposphere is where we live. Um, Pretty much everything we've talked about in this class has to do with the troposphere. So, ecosystems occur in the troposphere. Biogeochemical cycling, so the movements of nitrogen, carbon, oxygen, that all occurs in the troposphere. Weather and climate occur in the troposphere. And pretty much all of our pollutants that are in the air end up in the troposphere. Now, the stratosphere, the second layer, really the important thing here is that's where the ozone layer is. The ozone layer we'll talk about in topic 6.2. And besides writing them down, I don't think you need to know anything about the mesosphere and the thermosphere, except that they are our third and fourth layers of the atmosphere. And as far as I know, nothing important occurs in those layers. I've heard of a fifth layer called the exosphere, but the IB does not include that fifth layer. So again, 90% of atmospheric issues that we're going to talk about are in the troposphere, with the exception of 6.2, the stratosphere, because that's where the ozone layer takes place. Guys, off topic, but we can remind each other and myself. When is your planning in progress form due for your extended essays?
Tonight.
Today.
Okay. Have you guys already done that?
Yeah.
Yeah.
Wonderful. If you have not done that, that's a reminder for me that I need to go in and check my students and make sure that they've done it, so I can let Miss DeMay know. Um, but hopefully you guys can get that done. Maybe even right when we get done at 3 o'clock, you guys could do that. Okay. Moving forward, we see in order troposphere closest to Earth, then the stratosphere, then the mesosphere, and the thermosphere. Pressure gets lower and lower the higher you go. I do want you guys to draw this because this gives you, first of all, the important information that the troposphere is first and the stratosphere is second. But also, I want you guys to know the where these layers take place. The troposphere is from 0 to 10 kilometers up in the air, so that's about 6 miles up. Then the stratosphere is a pretty big layer. It goes from 10 to 50 kilometers, so like 6 to 30 miles. And I do want you to know that the ozone layer is sort of a dynamic, it's not like a true layer, it's just a part of the stratosphere that has a lot of ozone in it, but it is from around 15 to 35 kilometers up in the air. All right, one more drawing. I don't think you need to add anything, or I don't think you need to do a brand new drawing, but from the previous drawing, I want you guys to annotate that the ozone that occurs in the lower part of the stratosphere is good ozone. That blocks harmful UV rays from getting us. So that ozone is like, it's like a natural sunscreen. It keeps us from getting skin cancer and cataracts. But when ozone occurs in the troposphere, it is bad. It gets in our lungs and our eyes, and it can actually cause cancer and respiratory infections. So it's you can remember the rhyme: good up high, bad nearby. But basically, ozone is beneficial in the ozone layer, and it's detrimental when it's in the troposphere. Any questions about either of those graphics? Okay, so the atmosphere is made up of a bunch of different gases, and most of it is nitrogen, and nitrogen is an inert gas, meaning it really doesn't do a whole lot. It's not combustible. We don't breathe it out of the atmosphere. Remember, we need nitrogen to survive, but bacteria need to fix that nitrogen and make it usable in the soil before plants can absorb it and then animals can get it. Oxygen is about 21% of the atmosphere, and then that means the rest of the atmosphere is really small increments, about a percent of argon, 0.03% of carbon dioxide. That's pretty incredible when you think about climate change and all this warmer climate due to greenhouse gases. It's such a small part of the atmosphere, but these gases are really, really good at trapping heat, and so that small amount of carbon dioxide actually plays a really big role in the climate and the balance of Earth's ecosystems. Okay. Um, Now, I want to see if someone can chime in here. This is a tree that's been cut down, and there's a couple things we can learn from this. So I'm gonna give you the obvious one. We can learn how old this tree is. You guys probably learned this in like elementary school. You can count the rings. Let's say there's 26 rings. Okay, that tree is 26 years old. What else can we learn from this? If you look at like some of the details within the rings.
Like the distance between the rings.
Okay, does can anyone guess or infer what does that mean? So I see like here there's a lot of distance between the rings, and here the rings are really, really close together. So what can we infer about planet Earth, or the local area of this tree that made those rings really wide or really narrow? Well, I'll give you guys a hint. It's a growth ring. So what would make a growth ring really, really wide, and then what would make a growth ring not so wide?
Water?
Yeah. So, who said that? I can't see you guys.
Raya?
Good job, Ryan. Um,
You?
it's kind of cool to think that in these years, do you guys see my cursor? Sorry, I know I keep asking.
Yeah.
Okay. Um, in these years right here, where these rings are really close together, the tree barely grew, and so we actually know that that was a drought. And then here, when the tree was young, we see that the tree grew a ton each year, so we actually know that that was a really wet time. And so we can actually go back. Let's say this tree was cut down last year, 2019. 2018, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8. We can basically infer that there was a drought from the year 2008 to 2012 without anyone being there in 2008 to 2012 just by using this tree as like a nature time machine. Um, I know I can't see your faces, but are you guys all amazed and shocked? Jaws on the floor?
Yes.
Thank you.
Yes.
So, does anyone know what the. Okay, so a tree is kind of cool that we can go back. Some trees are a few hundred years old, and we could cut them down and find out about what the atmosphere was like a couple hundred years ago. Does anyone know, like on a molecular level, something that it's sort of like tree rings, but we can go back like hundreds of thousands of years?
Rock layers, maybe?
Oh, you're on the right track.
Yeah, I don't know. Soil?
Nope. I'll give you a hint. You have to go really far away to get to these things. You kind of drill into them like you're drilling into rocks, but you're taking out like a long core, a long sample.
Art.
Someone said it.
gonna say the Arctic.
Yeah, so we go to Antarctica, um, or the North Pole, but usually Antarctica. We find big sheets of ice that have been around for hundreds of thousands of years. We drill into it, we take a core out, and then we can look on the molecular level when this uh, iceberg was being formed. What was the temperature like? How much CO2 was there? What other gases were there? So basically, all you guys need to know is that we learn about the atmosphere's history from ice cores. Very similar to what we just saw with the tree rings, but imagine that that tree ring went back, 200,000 years, and we could learn about, was there a drought? Was there a wet year? Was there a time when there was a lot of CO2 in the atmosphere, meaning it was warm? And we do that by basically drilling into ancient ice down in Antarctica. So an example of the correlation here between CO2 and temperature, you guys know that CO2 is a greenhouse gas. It traps heat. So throughout the Earth's history, when CO2 has been high, we see that temperature has also been high. When CO2 has been low, we see that temperature has been low. Obviously, CO2 being the independent variable, temperature being the dependent variable. At the very present, we see both of them going much higher than they've been in recent geologic history. So now a little bit about the greenhouse effect is that the Earth retains heat because of gases in the atmosphere. And I want you guys to make sure that you star or underline that this is a natural occurrence. There's a big misconception that the greenhouse effect is man-made, or that we caused it. We have added to the greenhouse effect by putting methane and extra carbon dioxide into the atmosphere. But the greenhouse effect is absolutely natural. In fact, it's a good thing. Without the greenhouse effect, we would not be here. The Earth would be way too cold because there wouldn't be any heat being trapped here. We'd be a block of ice. So the greenhouse effect's a good thing. The main greenhouse gases, in order, carbon dioxide because of its prevalence, methane, even though there's not a lot of methane in the atmosphere, it's like 20 to 25 times stronger than CO2. Water vapor, which is a natural greenhouse gas, humans don't have much of an impact on that. And then lastly, NO2 and NO3, which together are just referred to as nitrous oxides.
Mr. Carden,
Yeah.
as for like agriculture and meat consumption, do they release more CO2 or methane?
So meat releases methane because cows burp and fart a lot of methane, but globalized agriculture in general releases a lot of CO2. And when you think about that, that's like cutting down and burning a forest to clear land releases CO2. All of the tractors and diesel machinery to till the land, that releases CO2. But yeah, cows are the one part of agriculture that mostly release methane.
Okay, thank you.
Okay? Um, the greenhouse effect, again, I know we've talked about it before, but basically what happens is that the ground gets heated by light. The heated surface then emits that infrared light. Infrared light's basically another way to say heat energy. Now remember, most of the Earth's atmosphere are not greenhouse gases, so most molecules in the atmosphere basically don't interact with heat. However, water vapor and carbon dioxide and methane, the greenhouse gases, they trap the infrared radiation basically they absorb it and then re-emit it back towards the Earth. And so then that increases the temperature of the atmosphere. And so obviously that small amount of greenhouse gases is in a form of dynamic equilibrium. But if we get more and more of those greenhouse gases, then they're going to be trapping and re-emitting more and more heat, more and more solar radiation, and that's going to cause the temperatures to go up. You do not need to write down as detailed. You could summarize this. You could also use the diagram on the right. Like, I know I'm a visual learner. I'd probably be better off drawing the picture on the right and studying from that than trying to like learn linguistically step by step. So I'll give you guys, I'm going to fill up my water, but I'll give you guys like 2 minutes to either summarize on the left, draw the picture on the right, or both.
Can someone tell me what the greenhouse gases are? I did not write them down.
I got it, everybody.
Okay.
Carbon dioxide,
Okay.
methane,
Yep.
water vapor,
Yep.
nitrous oxide.
Thank you, Nancy. Wait, how do you split? And never mind. Thank you, Nancy.
Any questions? All right, we should, those of you that have the meeting, we should be able to get wrapped up like right by 3 o'clock. But anyways, we will keep moving forward. Again, example of this, think about a car in a warm parking lot. The sun's energy absorbs through the windshield, so that'd be like coming through the Earth's atmosphere, but then the windshield sort of acts like a like greenhouse gases. It traps some of that heat from getting out. If you had a really thick windshield, the car would get hotter because you're still allowing the same amount of solar energy in, but you're trapping a lot more of that heat inside the car. Again, just looking at the comparison between the natural greenhouse effect on the left, and then, well, what about when we have more cows, so more methane? We're burning more coal, so that's more nitrous oxide, more carbon dioxide, and that's going to cause the same amount of solar radiation to get in, but less heat is escaping back into outer space. Actually, this diagram, does the arrow on the right, solar radiation, look bigger than the arrow on the left for solar radiation?
A tad bit.
Yeah, so I think that's inaccurate because it's not like the sun is getting any hotter or warmer. It's that more of its energy is getting trapped. So I can't tell if it's an illusion or not, but if this arrow is bigger, that's a bit of a false advertisement. Anyways, a couple more things to learn about in terms of just the details of the atmosphere. This one's probably the most complicated, so I don't think 6.1 is complicated in general, but the albedo effect might be the most, I guess, complicated part. Albedo is simply the amount of energy that a substance reflects or absorbs. It almost always has to do with how light or dark an object is. And you guys probably already know most of this. If you wanted to reflect sunlight, what color shirt should you wear in July if you want to reflect sunlight and stay cool?
White.
Correct. And if you want to absorb sunlight and stay warm, what color shirt should you wear in
Black.
January? Yeah, exactly.
I have a question about that. Is it just heat, or would it also be like the rays of the sun? So like if you're trying to like tan, would you wear black?
No, if you wanted to tan, you would wear white. Well, you can't get like tan through a shirt, but let's say you would be better off like if you were surrounded by white, that would be similar to being surrounded by mirrors, so you would get tanner than if you were like surrounded by black.
Okay.
Good question. Um, so clouds reflect a lot of solar energy. They also trap heat below them. It's kind of interesting that you might notice it this summer. Cloudy nights are warmer than clear nights because all the heat from that day ends up getting trapped underneath the clouds, and so it'll stay warmer if there's clouds out at night. Um, you have a big part of the albedo effect is polar ice. And so if you look at this like satellite view of the Earth, the fact that most of the top of the Earth is white, is that going to keep the planet cooler or warmer?
Cooler.
Cooler. Here's the problem though. Every year as it gets a little bit warmer, more of this ice melts. And as this ice melts and falls into the ocean, you're going to get less white on planet Earth and you're going to get more of that dark blue from the ocean. And so as ice melts and you get less white and more blue, are we then trapping more heat, absorbing more heat, or reflecting more heat?
Absorbing.
Absorbing. Meaning that's going to cause even more ice to melt. That's going to cause even more absorption of heat. That's going to cause even more ice to melt, more absorption of heat. What am I referring to that this one thing is going to cause a trigger?
Global warming.
Yeah, but something specific in ESS term.
Positive feedback.
Very good. Yeah, it could be a tipping point, specifically a positive feedback loop. Good. All right, and then the very last thing for atmosphere is atmospheric circulation. The sun warms air on the surface of the earth. Warm air rises, cool air falls. This leads to circular air movement, also known as wind. So you may have not known this, but believe it or not, even the wind comes from the sun. Pretty much every form of energy on earth comes from the sun. Coal and oil and gas come from the sun because that came from photosynthesis millions of years ago. A wind turbine is utilizing energy from the sun because the sun creates wind on planet Earth. Some other flow of the atmosphere is called convection currents, and this is the fact that the Earth rotates. Hold on, I got to think about this. The Earth rotates from east to west, and so that means that the air flows from west to east due to basically a lag due to that rotation. An example of this, if you guys look up a flight time from Detroit to Los Angeles, it might take about 5 hours to get there, but if you look at a flight time from Los Angeles to Detroit, it'll only take about 4 hours. And that's because there's pretty steadily circular airflow going from California to Michigan, going from west to east. And I think, you can jot this down quickly, that air pollutants can cause harm hundreds or thousands of miles east of where they're emitted. So, for example, anyone know if you're in Northern California, which is a pretty like pristine and scenic area, but you're dealing with some air pollution, anyone have a guess where that air pollution might be coming from?
Josh said Japan in the comments.
Close. Probably China. Shanghai, Beijing, some of the more polluted areas. Yeah, geographically it would come from Japan, he's right, but Japan isn't a big polluter. They're fairly advanced with the type of energy they use. We'll get into this with acid rain, but like Pennsylvania was dealing with a ton of acid rain. It was coming from Ohio. I think, what's just east of Germany? I don't know. Someone help me.
Josh said Poland.
Thank you. I think it was then Poland who sued Germany because they were dealing with a lot of the pollution coming east from Germany. All right, and then last but not least, atmospheric ocean interaction. Really, you don't need to know the details. You just need to know that the ocean plays a major role in the effect of the climate, the atmosphere. It helps to moderate and direct our atmosphere. A good example of this is El Nino. You guys may have heard of the El Nino weather impact. If you don't speak Spanish, El Nino means the Nino. Hey, I got a laugh. That was my first ever virtual joke that got a laugh. Good job. Yeah, it means the boy, but El Nino, when we have an El Nino year, you see Michigan ends up with a really warm winter, whereas Mexico and the southwest United States gets a really wet winter. Um, Often the year after an El Nino, there's another weird weather pattern. Anyone want to take a guess? It's kind of the opposite of El Nino.
La Nina.
Very good. La Ninas often occur after an El Nino, um, where we get like colder polar jet streams coming through. Um, it's not quite a polar vortex, but it's like a similar pattern. And scientists don't totally know why El Ninos and La Ninas happen. They do know that it's the Pacific Ocean current that has a major impact on this. Basically, the natural currents of the Pacific will randomly reverse on certain years, and it changes the entire climate of the Earth. And so it's an example of where the ocean has a huge impact on global climate. Like, we may just look at this as like, oh wow, it means I better get a new jacket this year. It's going to be really cold. Or, oh, I can't go skiing this year. It's going to be really warm. But if you're a farmer, this stuff's really important to know if you're going to have a cold year or a really dry year. And so El Niños and La Niñas are pretty major global events, especially for people that rely on climate for their living, such as farmers. What's interesting though is that they used to occur every 15 years, roughly, but in the last 15 years, it's actually happened 6 different times, and it is probably because of climate change. But again, this is one of the least understood aspects of climate. We don't totally know what causes El Nino to happen, but the fact that it's happening more and more leads us to believe that it's probably due to changes in probably because of climate change. Any questions about that? All right, I believe that's it for 6.1. So let me pull up the agenda for today. So again, guys, I know I talked about the planning section a lot. If you wrote a really weak or brief planning, don't just turn it in to get it done, because please realize that this is going to be a big grade senior year. It's also going to be part of your IB diploma grade. So take one more weekend to really fine tune it, and then turn it in, Sunday or Monday or Tuesday. I'd rather have a really good copy late than a rushed copy done today. And then your homework, which we will check in on Monday, is the layers of the atmosphere packet. I believe it's a 3 or 4 page packet where you read about the atmosphere, answer some questions, make a graph. I can't imagine it would take longer than 30 minutes. So that is all I have on my end. Before we get going, guys, before you guys sign off, can you just write a message that says hi, so I can jot down who's here and who's not here? Not for attendance, no one's in trouble, but I mostly want to find out, are there people that can't make the 2 p.m. or do they just forget about it?
If we turn in our planning late, like our context and planning, will we be penalized for it if we turn it in next week?
But I would, I know, Amaya, you had talked to me about, you didn't know how detailed the planning should be. I'd much rather have you spend time on it this weekend. You will not lose any points for that.
Okay, thank you.
Raya and Claudia, what was the instructions? What were you supposed to write?
So sorry. Hi. Not hello.
Can you guys redo that, please?
Yes.
I don't know why I'm being mean. I'm just sorry. I just thought that was funny, but it's not. Okay, I think that's it. Is Phoebe still here?
Yes.
Phoebe, did you have more questions about your research question, or did you want to set up a meeting on Friday, or do you think you're okay?
No, I'm good. I am almost done with my context now, and so then I just have to tweak the planning.
Okay, that sounds great. And I have time right now. Does anyone have questions about their IA, or does anyone want to set up a brief meeting on Friday, or do you guys feel pretty good?
I want a meeting, just a quick one.
I hear someone talking, but it's not very loud.
Oh, that was me.
Okay, go ahead.
I just wanted a quick meeting on whatever day you're available.
Sure. Let's how about, well, if no one else has questions, we can meet right now.
Oh, I have to go to bio real quick. I mean, I can be late.
Sure. Yeah, we can go over your questions. So does anyone else, before I meet with Nancy, does anyone else have quick questions or want to meet on Friday?
Mr. Carden, I have a quick question.
Sure.
So, if we're doing a survey for the procedure, you want us to write what questions we're going to ask in the survey, in the procedure?
Yep, exactly.
Okay, thank you.
Any other quick questions?
I don't know if this is a quick question or not, but I was wondering like how do you exactly do like biomass? Cause like since I'm doing like hands-on, like I don't know if I just want to calculate the height. Like I was trying to do like maybe biomass of it as well.
Yeah, you can use your oven at home, and it's the same thing. Just turn it on the lowest temperature possible. So, like, if you can do like 100 degrees or 150 degrees, leave it in there for like 2 or 3 hours. Take it out. If it still seems a little wet, put it back in 100 degrees, 2 more hours, and then once it's like dried out, that's it.
Okay, thank you.
But I would also do height and biomass and qualitative just so you have more than enough
Yeah.
data.
I just wanted to have more than just height.
Yeah,
Yeah.
exactly.
All right, thank you.
Yep.
Mr. Carden,
Yes.
may I set up a meeting on Friday?
Sure. I'm pretty. Let's do this. What time works for you? I think morning is better for me.
Yeah, morning is better for me as
Okay,
well.
so what time?
Is like around 10 or 11, okay?
Yep, let's do 10 a.m.
Okay.
So I won't set anything up. I'll just get on Skype at 10 a.m. and then I'll call you.
Okay, thank you.
Anyone else want to schedule a meeting or have quick questions before they go?
I have a quick question about like the explanation of variables in the material list for a survey.
Yeah.
Because for the variables, I'm doing like political parties, and control variables would be political parties and country. How would I explain that if it doesn't have like a set value?
You don't have to do that table. Like there's no rule that says like you have to have like all the biggest variables are the independent and dependent, but yeah, the method needs to make provision for sufficient relevant data. Variables are not necessary. So you're if that variable table is not coming naturally, don't force it. Just forget that whole thing and just make sure that you justify like the reasoning for your sampling strategy.
So I don't really need the table then.
Nope, you won't lose any points for not having the variable table.
So it's only the justification and sampling then?
Yeah, exactly. And some students, in that variable table, they'll make a column where they justify those different variables, and that can help the justification section. But if you are already going to make a section or a paragraph or table about justifications already, then you don't need that table. You don't need the variable table.
All right, and for a survey, what do I do as a materialist? Because all I can think of is like a computer with functioning internet and like a Google survey.
Yeah, you could, for materialist, you could just say internet connection and like the URL to the survey.
All right.
Good questions.
Mr. Carden.
Yes.
So when I was writing my context, cause I'm doing how their EVS affects their food choices, but because I'm doing it in terms of like carnivore or vegetarian diet, I'm kind of stuck because of like I asked you earlier about the meat emissions and agriculture emissions, because it seems like meat produces more methane, and then agriculture or like a more like plant-based diet is more of a CO2 emission.
Well,
So
there's one thing you're forgetting though, that it's okay. So when you eat meat, there's all those cow methane emissions that you're responsible for. And when you think of it, when you're eating vegetables, there's all that CO2, but the cows need to eat all those vegetables too. So if you're a meat eater, you're still ending up with all the same CO2 emissions because we need to grow 10 times as much corn or soy to feed to the cow to get to us. So if you go back and look at the PowerPoint from section 2.2 and 2.3, you'll see some stuff about like trophic level efficiency, where we talk about why it's so much more efficient to be a herbivore than a carnivore.
Okay, and can I also set up a meeting on Friday after Raya?
Yeah, how about 10:15?
All right, sounds good.
Yep.
Thank you.
What else? All right, guys. If you don't have anything else, that's it for me. So your homework, if you guys want to get started now, it's a pretty straightforward packet on the atmosphere. I'm available tomorrow morning. I'm sorry, Friday morning. So if anyone else wants to meet, I could meet at 9:45 or 10:30. Just send me an email, and I'd be happy to have a quick Skype call with you guys. All right. Claudia Lee. Evelyn.
Bye, Miss Carden. Thank you.
Bye.